Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of trigonometry functions. So as per the problem, sine theta is equal to 11 over 20 and theta lies in quadrant 2 and we have to find the exact value of sine 2 theta, cos 2 theta and tan 2 theta. So the first step here is to draw out the given angle on the quadrant. Now as per the problem, the theta lies in quadrant 2. So we can show angle theta like this in quadrant 2. So this angle here is equal to theta. Now we are given that sine of theta is equal to 11 over 20. So we can use these values as side lengths in this right angle triangle. So this is a right angle triangle. So we know that the formula for sine, so I'll write it here. So sine is equal to opposite over hypotenuse. So this is the formula as per SOHCAHTOA. So in this case, the opposite side length is 11 units, so which is this vertical side in this triangle, and the hypotenuse is this longest side or the side opposite to the right angle, and this is 20 units. So this is the given information in the problem. Now before we find the value of sine 2 theta, we should find the length of the third side in this triangle, and the third side is this horizontal side. So we can use Pythagorean theorem because it's a right angle triangle and we know the length of two sides. So the Pythagorean theorem equation is a square plus b square equals c square. And in this equation, a and b represents the vertical and the horizontal side and c is the hypotenuse. So we can sub in the values. So let's assume a is 11. So 11 square plus b square equals 20 square. Now we can evaluate the squares. So 121 plus b square equals 400. So 20 square is equal to 400. Now we can evaluate b square by subtracting 121 from both sides. So the 121 on the left side cancel each other out and we get b square equals 400 minus 121, which is equal to 279. And now we have to change b square to b. So for that, we'll have to apply square root to both sides, because the square and the square root on b will cancel each other out. So the third side length is equal to square root of 279. Now we can simplify this expression square root of 279 by breaking down 279 into its prime factors. I can show you the steps here. So 279 can be broken down as, so 3 times 3 times 31, because 3 times 3 times 31 is equal to 279. So these two threes will come out as a single 3 in front of the square root, and we get the value of b as 3 times square root of 31. Now we can use this value of b to find the value of sine 2 theta. So this b represents this third side length here. So I'll show it in a different color. So this horizontal side length, which is 3 times square root of 31. Now we have to find the value of sine 2 theta. So the first step is to use the double angle identity for sine here. So sine 2 theta can be written as 2 sine theta cos theta. So that's the double angle identity for sine. In the next step, we'll sub in the values for sine theta and cos theta. And we are given that sine theta is equal to 11 over 20. Now in quadrant 2, cos will be negative. And for cos, the formula is adjacent over hypotenuse. So the value of cos theta will be negative 3 times square root of 31 over 20. So the adjacent side length is 3 times square root of 31. Now we can multiply these fractions. So when we multiply fractions, we multiply the numerator numbers and the denominator numbers. So for 2, the denominator is 1. So we have to do 2 times 11 times negative 3, which is equal to negative 66 times square root of 31 over. Now in the denominator, we have to do 1 times 20 times 20, which is equal to 400. Now we can simplify this fraction. So we can reduce this fraction by 2 because 66 and 400 are even numbers. So our final answer here should be negative 33 square root of 31 over 200. So this should be the final answer for part A, sine 2 theta. Now we can work on part B, cos 2 theta. So I can use a different color here so that there is no confusion between the steps. We'll have to use the double angle identity for cos. Now the double angle identity for cos comes in 3 forms. So the easiest one will be the one which has just sine theta in it because we are given the value of sine theta, and that is 1 minus 2 sine square theta. So now we can sub in the value of sine theta. So sine theta is given as 11 over 20, and we put a square on it because it is sine square theta. Now we can evaluate the square. So we get 1 minus 2 times. So 11 square is 121 and 20 square is 400. Now we can multiply 2 by the fraction. So the denominator of 2 is 1. So we multiply the numerator terms. So we get 1 minus 242 over 400. Now we can simplify this fraction. We can reduce the numerator and the denominator by 2 because both are even numbers. So we get 1 minus 121 over 200. And now we can subtract these terms. So the denominator of 1 is 1. So the common denominator here will be 200. So we'll multiply the numerator and the denominator in the first fraction by 200. Minus 121 over 200. Now we can subtract the numerator numbers because the denominators are the same. So I get 79 over 200. And this should be the final answer for part B because we cannot reduce this fraction. So we are done with part B, and now we can work on part C. So in part C we have to evaluate tan 2 theta. Now we know that tan can be broken down into sine over cos. So our first step is to do that because we already know sine of 2 theta and cos of 2 theta. So we can rewrite this as sine of 2 theta over cos of 2 theta. Now we can sub in the values for sine 2 theta and cos 2 theta from part A and B. So for sine 2 theta we got negative 33 square root of 31 over 200 over 79 over 200. Now this is a fraction over a fraction. So the first step here is to write it as a division statement because that will make it easy to simplify this expression. Divided by, so 79 over 200. Now we can change it into a multiplication statement by flipping the second fraction. Times, so we get 200 over 79. Now we can cancel out the 200s. So we are able to cross reduce the 200s. So now our final answer will be, so we get negative 33 square root of 31 over 79. This should be the final answer for value of tan 2 theta. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.